Hi everyone, welcome to Organic Insight. In this particular video, I am going to discuss how to find the hybridization of carbon. First of all, if a molecule is given and you have to find the atomic hybridization of one particular carbon atom, the what we have to do is just we have to count count the number of atoms connected to the particular atom. Count the number of atoms connected to it. This is the first point. We have to count the number of atoms connected to it. And the second one is count the number of lone pairs. Count the number of lone pairs. Here, in the first point, I'm telling count the number of atoms, but here I'm not telling about bonds. Only connected atoms I am telling. Then in the third point, what we have to do, we will get a number over here and we have to add that number. Add both 1 and 2. Now, here if we get the number it is 4, then that particular carbon atom is sp3. It is not only regarding carbon, it can be any. And if it is 3, it is sp2 hybridization. If it is 2, it is sp hybridization. Here I will show with example how this trick will work. Now, here I will consider a simple molecule, methane. Now, the first point what I told is we have to find the hybridization of this carbon atom. We have to count how many atoms it bonded. 1, 2, 3, 4. Total it bonded to 4 hydrogens. In the second case, if any lone pairs is there, no, here I am not finding lone pair. That's why 0 I will put. We have to add both of this. How it 4 plus 0 is 4 only. If 4 it is coming, it is sp3. Right? In the previous slide, we already saw this. If 4 if it is there, it is sp3 hybridization. Now we'll look on the other example. Simple molecule ethene I will take here like this. Now I have to find the hybridization of this particular carbon atom. Now the first thing is to which how many atoms this carbon is attached, the carbon number, this carbon and this 2 hydrogens. Total 3 atoms it is attached. Any lone pairs is there? No, 0 lone pairs is there. And if we add the both of this, it will become 3. If 3 is there, it is sp2 hybridization. Same thing will happen in this case also. This will also will come sp2 hybridization. Now we'll move on to the next example. Before this, I will discuss one alkyne also. Here I will take carbon-carbon triple bond is there, simple molecule acetylene. Suppose if I want to check the hybridization of this particular carbon atom, now the first thing is to how many atoms this carbon is attached, this carbon atom and this hydrogen atom. Total 2 is there. Any lone pair is there? No, 0 lone pairs. If we add both of this, it will become 2. If 2 is the number, it is sp hybridization. A simple table we can make over here. Here only I will just erase this and I will write the output of this. Here what actually we are doing, it is electron count we are doing. I will just write it as electron count, and here I will write hybridization. Suppose if electron count or electron group we can tell, if this one if it comes 4, it is sp3 hybridization. If it is come 3, it is sp2. If it is 2, it is sp hybridization. If we remember this table, it is more than sufficient for us to calculate the hybridization of any atom. Now we'll see the example. Now I am showing one molecule. Suppose randomly I will take one carbon atom. Suppose this carbon atom, I have to find the hybridization of this particular carbon. Now first thing is same, the how many atom this carbon atom is attached. It is this carbon atom and this carbon atom, only two atom it is attached. Then if any lone pairs is there, lone pairs we know, suppose if any molecule is there like this, lone pairs we will show by two dots, something like this. It is not there, that's why zero lone pair is there in this case. That's why if we add both, it will become 2, which is sp hybridization. Now we'll see the another molecule. This molecule is called as allenes. Allenes we can call. Suppose if I want to know the hybridization of this particular carbon atom. Now the first case is to how many atoms this carbon is attached. This carbon and this carbon. Total 2 is there. Any lone pair is there? No. Zero lone pair is there. That's why total it will become 2, therefore sp hybridization. If you check this carbon atom, it will come sp2 and this carbon also sp2. Then we'll move on to the next thing, carbon monoxide as well as carbon dioxide. Now this carbon atom is attached to only one atom, it is oxygen. That's why the first case it will be only 1. Now here, any lone pair is there on this carbon atom? Yes, because of this lone pair, I am writing negative charge over here. That's why one lone pair is there. One lone pair. Total, it will become 2. That's why it is sp hybridized carbon atom. Now, we'll see about the carbon hybridization in carbon dioxide. This carbon is attached to two oxygen, two atoms, correct? That's why the first case it is two atoms it is attached. In the second case, no lone pair is there. That's why zero lone pair. Total it will become 2. Therefore, it is also sp hybridization. This trick will work on any other atom, more not only for carbon. I'm telling, suppose if I want to write for this carbon atom, this particular, this group is called as nitrile group. Suppose this carbon atom is attached to two other atoms, that is carbon and nitrogen. That's why two atoms it is attached. And in the second case, if it has a lone pair, no lone pair is there. That's why zero lone pairs. If we add both of this, it will become 2. Therefore, it is sp hybridization. Now, we'll see some special case, that is carbocation. This is carbocation and this one is carb anion. Now, I have to find the hybridization of this carbon as well as this carbon. Suppose this carbon is attached to 3 other atoms, that is 3 hydrogens, correct? I have to write the first case as 3 atoms it is attached. In the second one, lone pair is there? No, zero lone pair is there. Zero lone pair. If we add both of this, it will become 3. That's why it is sp2 hybridized, which is, what is the geometry of this? Trigonal planar. Now, I want to know about the hybridization of this particular carbon atom. It is attached to 3 hydrogens, correct? Therefore, 3 hydrogen atom it is attached. And in the second case, any lone pair is there? Yes, we can see one lone pair over here. That's why I will write one lone pair. If we add this, how much it will become? 4. That's why this carbon atom is sp3 hybridized carbon. Now, this is also intermediate. This is carbene. This is carbene. Now, I want to know about the hybridization of this carbon atom. The, to which, to how many atoms this carbon is attached? Two hydrogens. That's why the first case it is two atoms it is attached. And any lone pair is there? Yes, we can able to see one lone pair. Total it will become 3. If 3 is there, it is sp2 hybridization. Now, other than carbon, we can see over here this oxygen. Oxygen, if it is attached to other atom, it will have two lone pairs. I will be showing two lone pairs like this. Now, I have to find the hybridization of this oxygen atom. The same rule will applicable over here. To how many atoms it is connected? Two hydrogens. That's why it is two hydrogen atom it is connected. And in the second case, how many lone pair is there? Pair means two we have to tell. That's why this is one pair and this is another pair. It is two lone pairs is there. That's why total it will become 4, which is sp3 hybridization. Now I have to find the hybridization of this nitrogen atom here. This nitrogen atom is attached. Okay, I will show in complete form. Something it will look like this. Hydrogen and this is hydrogen. The first case it will become, to how many atoms it is attached? One hydrogen and one carbon, correct? Total 3 atoms it is attached. And for how many lone pair is there? One lone pair is there. That's why total it will become 4. That's why it is sp3 hybridization. I think this video is helpful for you people. Thank you very much for watching.